Welcome back to another video. In this video, we are going to talk about tree diagrams which come under probability. Let's get started. So, first of all, what is a tree diagram? It helps us to calculate the number of possible outcomes of an event by arranging the outcomes in an organized way. So, if you know probability, it is basically finding the possible outcomes of having something. Let's take an example. If you flip a coin, there are two possibilities, a head and a tail. So the probability of having a head is 1 out of 2. This one is this head, and this 2 is the total possible outcomes available to us. Alright, let's move on. So we first take an example. A bag contains 5 red balls and 3 green balls. A ball is thrown out at random and replaced. Another ball is withdrawn. What is the probability that both balls are green? So we have to make a tree diagram. A basic structure of tree diagram you will see over here, step by step. So we make a probability of red. It says 5 red balls. So 5 out of 8. Now how I got 8 is the total possible outcomes. And how did I get that? Is simply 5 plus 3. Because this 5 and this 3. So 5 out of 8. And probability of green is 3 out of 8. Simple. But if you say a ball is drawn, another ball is withdrawn, that means 2 times. This was for the first pick. Let's see for the second pick. This is the second pick. If you see, probability of red is again 5 out of 8, and green is 3 out of 8. Red is 5 out of 8, green is 3 out of 8. Now why so? Because here a very important word in the question is said is replaced. That means if you pick a red ball out, you see it and keep it back into that bag. So the total possible still remains it. And not only that, the total red balls also remain the same. Now what is the question? So this is the basic structure of a tree diagram. It says what is the probability that both balls are green. So both balls are green. 3 out of 8 into 3 out of 8 we get a probability. So yeah, here it is 3 out of 8 into 3 out of 8 is simple multiplication, 9 out of 64. Let's move on. This is a question. You may pause the video and answer this question. I will be answering this entire solution. A bag contains 6 red marbles and 4 blue marbles. A marble is drawn at random and not replaced. I am marking an important word, not replaced. 2. Further, another important word, are made again without replacement. Find the probability of 3 red marbles and at least 1 red marble. Now you may pause the video if you want to get the solution of this on your own, but I will be explaining it now. Now if you see it says not replaced, that is an important word, and 2 further, that is total 3 picks that are in this case. So let's see. First I drew a normal tree diagram. How will this be represented? So it's easier for me to answer both these questions, and even if there are more, it's more easy. Now I've not written for all, but I'll just tell you. Over here it will be P blue, okay? Here it will be P blue, here it will be probability of blue, probability of blue, probability of blue, probability of blue, okay? So yes, so this is the probability of red, 6 out of 10. 6 plus 4, total outcomes 10, and red marbles there are 6. Now again the probability of red becomes 5 out of 9. 9 because For example, I pick up a red, I keep it in the side. So now the total number of marbles in the bag are 9. So the total outcome becomes 9. And the red marbles also decrease by 1. So it is 5 out of 9. Next, I make a third pick. So I will remove 2 on the side. So there are 8 left. And if both become red, the third one I pick, if it is red, it has only a 4 out of 8 probability. So here is 4 out of 8 as a probability. Let's move to this 6 out of 10. Now if after one red I pick one blue, the total blue will be 4, so I divide by 4 and total marbles are 9, so 4 out of 9. After this blue, if I pick a red, it is 5 out of 8. Why 5 out of 8? Because here only one red is picked and through this part. Now look at only this part, don't look at other parts. I will show you this, and this, right? So now you see there is only one red over here and second red over here. So before this only one red is picked up. So this will be not 4 but 5 out of 8. Similarly, if you pick a blue at this point of time, it becomes 3 out of 8. You see how your 1 is picked and it's out of 4, 1 gets at the side, so there are only 3 left, so 3 out of 8. Similarly over here till now no blue is picked. I will show you. Till here no blue is picked. So now blue is picked, which is the first pick. So there are total remains as 4 out of 8. Similarly, you make for this too. Similarly, I have made here a blue marble. Now over here no red marble is selected yet, so 6 out of 9 and 5 out of 8. Over here 3 out of 8. Why? Because your one blue marble is already selected. Here 3 out of 9. Why? Here why 6 out of 8? Because no red marble is selected yet, and here 2 out of 8 because all of them. Now let's look at the question. It says 3 red marbles. So 3 red marbles means red, and red. Simple as that. 6 out of 10 into 5 upon 9 into 4, 8. 6 into 5 into 4 you get as 120, 10 into 9, 90 into 8 you get 720, 120 upon 720. Simplify, you get 1 out of 6 as the final answer. Use the in fractions, use the simplest form as possible. Now the next question is at least one red marble. So at least one red marble means there can be 3, there can be 2, or there can be 1 red marble also. But there should be minimum 1 red marble, minimum, right? So here the possibilities increase. And now you should not calculate this and this and this. There's simpler way, which over here I have calculated first the probability of 3 blue. Why? Because if this probability is done, this 3 blue, that is the only case where no red marbles are used. In all other cases, at least one is still used, which makes our things easier. So 3 blue marbles ka probability is 1 out of 30. So 4 into 3 into 2 gives you 24, and 10 into 9 into 8, 24 upon 7, 25, 1 upon 30. Now at least one red marble it's not asking for 3 blue, it's asking for 1 red. So as you must be knowing, the total probability of anything is 1. So you subtract this 1 upon 30 from this 1 to get your final answer, which is 29 upon 30. Now if you are free enough to answer it in the long way, you can. 6 upon 10 into 5 upon 9 into 4 upon 8. Additionally, this into this into this. There's too much. I am not that free, so I did it the very simple way. So yes, this was the end of this video. Hopefully you like the video. Please subscribe down below. If you have understood a bit also about tree diagrams, if any queries, let me know. Thanks for watching.